Hello. In the practical paper, you must beware of beautiful numbers. I'll show you why. So here in the question paper, you're asked to set x to be roughly 30 cm, and then later in this part, you're asked to record the value down. So you follow the instructions, set it to about 30 cm, and then you record down the value 30 cm. Dang! You have lost the mark. How come? Because whatever you write down here must reflect the precision of the measuring instrument. And since you are using the ruler, which has a resolution of 1 mm, instead of 30 cm, you have to write down 30.0 cm. Now, beautiful numbers are even more dangerous in the table. I'll show you why. So, x is measured using the meter rule. So, all these numbers here are written to the nearest 0.001 meter, to the nearest 1 mm. Now, you are going to calculate 1 over x. So 1 over 0.05 is 20, right? So you write down 20. No problem with this. Now, what about 1 divided by 0.1? That's a 10, isn't it? Dang! You have lost the mark. Because whatever number you write down here must reflect the uncertainty of this number. And since this number is calculated from 0.100, which is a 3SF number, you have to write 10 as a 3SF number as well. So you have to write down 10.0. So why was 20 correct? Because 20 was calculated from 1 divided by 0.050, which is a 2SF number. So it would be wrong to write 20 as 20.0. So 20 here has to be written to 2SF only. Let's continue, yeah? 1 divided by 0.15 will be 6.67, 3SF number. Let's continue. What is 1 divided by 0.2? You cannot write down 5, yeah? 5 is too beautiful already. 1SF numbers are too sexy. They are very dangerous. Watch out, yeah? So because it's calculated from a 3SF number, you have to fill in the zeros here to make it a 3SF number. Likewise, 1 divided by 0.250, you have to write it to 3SF. Similarly, 1 divided by 0.3 should be written as 3.33. Okay, let's look at another example here. So I is measured using a multimeter with a precision of 1 milliamp. That's why all these numbers are written to the nearest 0.001 amp. And V is measured using a multimeter with a resolution of 0.1 volt. That's why all these numbers are written to 1 dp. So now we are going to calculate I times V. So what is 0.050 times 2.0? If you press the calculator, you may see the number 0.1, but please don't write down 0.1 because this number is calculated from multiplying a 2SF number with another 2SF number. So the result should also be written to 2SF. So you got to fill in a 0 here, 0.10. So what about 0.100 times 4.0? So that's a 3SF number multiplied with a 2SF number. The calculator will tell you 0.4, you got to fill in a 0 to make it a 2SF number. We are always constrained by the less precise number. So if one of them is 3SF and the other is 2SF, we have to stick to 2SF. What about 0.150 times 6.0? That's a 3SF number multiplied with a 2SF number. So we have to write the answer as a 2SF number. So 0.90. Now 0.2 times 8 is 1.6. Do we have to fill in any zeros? Well, we are multiplying a 3SF number with a 2SF number, so we are stuck to 2SF. And 1.6, yeah, is a 2SF number. So please don't fill in a 0 here. So you see, as you go down the column, you may not end up with the same DP. You just have to process row by row and follow the least SF of the numbers that you used in your multiplication. The next one is similar. We are multiplying a 3SF number with a 3SF number, which means the answer has to be written to 3SF as well. So it's going to be 2.50. So 1.6 is 2SF because 8.0 was a 2SF number. But 2.50 is a 3SF number because 10.0 is a 3SF number. See? The DPs are not consistent down the column, but the SF has to be consistent across each row. Okay, let's finish up the last one. We have a 3SF number multiplied with a 3SF number. So the answer has to be written to 3SF. So it's going to be 3.60. So in the practical papers, you must be very suspicious of beautiful numbers. If you are writing down 1SF numbers like 0.1 or 0.4, you better double check because it's very rare to have 1SF numbers in practicals, because it's very rare to have 1SF numbers in measured data. If your measurement deserves only 1SF, That's a very lousy measurement, very poor precision. I don't think Cambridge will make you do such a lousy, low precision measurements during exams. In fact, the only time when you see a 1SF number in a practical paper are in those parts where you're asked to estimate the percentage uncertainty. Because it's an estimate, you have to write your estimated value to only 1SF. This is the only place where 1SF number is not a mistake. And in your table especially, since your raw data are unlikely to be 1SF numbers, the calculated values shouldn't be 1SF numbers. Remember, you got to process it row by row and follow the least SF number. Alright, that's all. Ta-ta!